Okay, hello everyone. Today we are doing functions, and the topics that will be covered here are introduction to functions, defining and calling void functions, designing a program to use functions, talk about local variables, passing arguments to functions. We'll discuss what's called global variables and global constants. We'll discuss introduction to value returning functions, generating random numbers, writing your own value returning functions, the math module, storing functions in modules. This is a big chapter, so we'll try to go as fast as possible so that I can show you some examples in writing functions or modules in Raptor as well as the Python. For your third assignment, it requires you to break it down, your second project, into modules, meaning that you break it down into functions or modules so that your main program only has few function calls rather than everything being in the same place. Functional module subchart, they pretty much mean the same thing. It's a group of statements within a program that performs a specific task. Like in your case, in the recent project that you had all your menus, right? You listed all the 5 menus, the 5 things you're selling. You want to put something like that in a function, and then you call that function. Okay. So usually one task of a large program, functions can be executed in order to perform overall program tasks. It's known as divide and conquer approach. So for those of you that already submitted, you saw that, I think a couple of you have already submitted. You had, similar to what we had in main, in the flowchart, you break it as subcharts. And those subcharts basically hold the same information that belong together. And then you're just calling that in the main function. So modularized program is a program where in each task within the program is in its own function. So a function is a module that returns the value back to the part of the program that called it. So many languages provide libraries of functions that you can use, such as random number generator functions is like a module, but it returns a value that can be used in your program. You have library functions, written functions that come with most languages, usually common tasks, and save time for the programmer because it allows for ease of use. So here are some examples of how to write a function in Python. So here you say define a function, and then parentheses. Remember, we're calling it a function. Even in math, functions have what? How do you know it's a function? The parentheses. All right. In other languages, we use braces to separate a block of code from the rest of the code. Here in Python, you use the 2:, and then you tap it. Now, if you run this is what it generates. The same thing in function 2 and so forth. Okay, so imagine writing this one line after the other. But here you can just write one function and call it multiple times. So the benefit of modularizing a program with function is simpler code reuse, write the code once and call it multiple times. Better testing and debugging. You can test and debug each function individually. Faster development, easy facilitation of a teamwork. Different team members can write different functions, and all those functions can be called in the main program. And you will find yourself, when you work for a big company, you're only given one part of that project, and that's the part that you write a function or that you write part of the program. And then everybody's code will be brought together to accomplish a major task. Right? You have what's called a void function and value returning function. So a void function simply executes the statement it contains and then terminates. That's it. And then you have a value returning function, executes the statement it contains, and then it returns a value back to the statement that called it. So the input, maybe an integer, and a float functions are examples of returning value functions, rather than calling it just a void function. So functions are given names. So function name rules, it cannot use keywords as function names, cannot contain spaces. Similar to variables, first character must be a letter or an underscore. All other characters must be a letter, a number, or an underscore. Uppercase and lowercase characters are distinct. Okay. Some of you had a problem in both in Raptor and I think also Python, that when you wrote or when you defined your variables, sometimes, yes, it was the same thing, but one was you started with what do you call it? Uppercase, another you had a lowercase. You have to make sure you're consistent. That's why I told you try to use a notepad. As soon as you define the first variable, put it in a notepad. Later on, when you need that variable, just copy it from notepad and paste it. Very important. Otherwise, if you just try to remember it, then you have a problem. I think somebody had something about burger or whatever it was. or nachos, whatever, however you define those variables on the menu that you were setting, one you had an S extra wherever it was, right? So make sure that you don't have those issues, but if you put it in a notepad, it will be much easier for you. Defining and calling a function, this is in a Raptor flowchart. So when you're flowcharting a program with modules, each module is drawn separately. This is a module, and this is where that module, so here it's like a show message, and all it has is display hello world, right? Now when you call the show message here, so every message that was in here will be displayed inside, part of this main program. And project 3 requires that you break your code down into parts like this. So subcharts in Raptor uses subcharts and procedures that function like modules as described in your text. In order to add a subchart, you right-click on main, and you will get the second tab for the second subchart, which you will name show message. So here's an example how it will look, and I'll show you an example. So here was the show message. Here's how it's called. So then we have defining and calling modules. So hierarchy chart gives a visual representation of the relationship between modules. And then the details of the programs are executed. As part of your project 3, besides the Raptor program, you also have to submit a Microsoft Word document. The Microsoft Word document would have the main, kind of like this, the hierarchy chart. And then the assignment requires, it doesn't need the subchart or the third row here. It only needs the first part. So you have your main, and then you have your other subcharts that you have created, other functions. Try to have at least 4 or 5. You can have more, but don't overdo it, okay? So that's part of the requirements. A Microsoft Word that's separate from the actual project that you're submitting on your project 3. So make sure you read the instruction. So a function name should be descriptive of the task carried out by the function, often includes a verb. So a function definition specifies what function does. So here you may have def function name and then statement. Just because you define a function doesn't mean it will get executed. You have to call it for it to happen. Okay. So you have the function header. First line of function includes keyword def and function name followed by parentheses and a column. You have a block set of statements that belong together as a group. Examples, the statement included in the function. Then we have what's called a local variable. A local variable is declared inside a module and cannot be accessed by statements that are outside of the module. And then we have what's called a variable scope, is the part of the program in which the variable can be accessed. Now, since I'm here at the local variable, so I actually have, so let's define the two. And then we have what's called a global variable that accessible to all modules, should be avoided because they make debugging difficult. Making the module dependent on global variable makes it hard to reuse module in other programs. They make program hard to understand. Let's go over this too. Let me finish this also. A global constant is a named constant that is available to every module in the program. Since a program cannot modify the value of constants, these are safer than global variables. Now I want to go back and explain to you what a local variable is, then a global variable, then explain to you what the scope is, these three. Okay? Now, do you understand the word scope? What is it used for? Here, in terms of program, it says a scope is the part of the program in which the variable can be accessed. Don't you hear the statement? Sometimes you ask somebody something, and then the person will be like, oh, that's outside of my scope. You hear that statement, right? What does that mean? When somebody says this is outside of my scope.
Outside of my reach.
This is outside of my reach?
Area.
So what does it technically mean? What does it mean when somebody says outside of my scope, outside of my reach, outside of my area, however you say it?
Outside of their ability to complete that task or whatever.
Outside, so that means I don't have access to it. That's basically what it means, right? I don't have access to that information. Now, when we talk about local variable and global variable, think of it like that. Now, a local, you know what a variable is, right? What is a variable?
A variable is a placeholder for a statement.
So it's a statement, it's a placeholder that can change. It says variable, so it can change. You can hold some information now, later on you can ask it to hold some other information for you. Now let's go back, so a local variable. Let's say we defined a variable here in this room. Let's think about this room to be a function, okay? Now, and we have a variable and we're calling it a variable named Ali. It's holding the name Ali for us in this room. So that means what? We have access. If we called Ali, Ali will be able to say, yes, I'm here. We have access to that. Now, next class, if they say Ali, would we hear it? If we call Ali, can they hear us? So Ali is only in our scope. We have access to it. But they don't have access to Ali here in this room. Does that make sense? So they can have their own Ali there, and we can have our own Ali here. Does that make sense? Consider that class to be another function. Okay, they can have their own Ali, and here we can have our own Ali. So each one is separate. However, if we have next to that tree another variable named Ali, we can look outside. Ali can see us. We can see him, and we can say, "Hey, Ali," and he will hear us, right? So we have access to that. That's our scope. That is global. They have access to it if they look at the window. The same thing. That is global. Remember, we're talking about local variable and global variable. So it's in our scope if it was inside our class. But if there is another variable outside both functions or both classrooms, outside they have access to it. That's global Ali. They have access to it. That is what? Global Ali. But the Ali that we have here is only private to us. It's local variable. And if they have their own local variable, they have access to it. We don't have access to it. Now, if I have Ali here, can I have another Ali in here? No, because if I say Ali, they will both say what? Here, it's too confusing. It causes an error. Which Ali do you want? So you have to call it Ali 1 and Ali 2. But having Ali in that room, there is no issue. Having Ali in this room, there is no issue. Does that make sense? Mm-hmm. So that's the difference. The scope is the accessibility of it. If it was outside, we have access. Both of us have access to it. If it's defined in here, then we have access to it. If they define their own Ali, they have access to it. So the scope deals with accessibility. We have the local defined in here and the global one. Is it clear? Yes, yes, yes? All right. So the global constant is a named constant that is available to every module in the program. It's a global. You define it once. In the case of like a tax rate, it's global. You define it once and everybody can access to it because it doesn't change it, right? And if you have to change it, if there's a new rule that comes up, then you can change it from there. All right. You can pass by value versus pass by reference. So pass by value means that only a copy of the argument's value is passed into the module, into the function. So one directional communication, calling module can only communicate with a called module. So pass by reference means that the argument is passed into a reference variable. So this is a two-way communication. Calling module can communicate with a called module. And the same thing, vice versa. So here's the local variable. So basically duplicate names within the same scope must have different names. This is what I was talking about, like having the same Ali. So here you have integer age, enter your age, input age, declare integer age. So this will cause error. You cannot say enter age here and enter age here. Does that make sense? Enter age 1 or age 2, however you want to say it, but not the same age. This is what I was talking about. You cannot have two Alis in here, right? So call a function to execute it. When a function is called, the interpreter jumps to the function and executes the statement in the block. So the interpreter jumps back to the part of the program that called the function, known as a function return. Passing arguments to modules. So sometimes one or more pieces of data need to be sent to a module. So an argument is any piece of data that is passed into a module when the module is called. The parameter is a variable that receives an argument that is passed into a module. Like in the case of math, you don't just say f and then empty parentheses, right? What do you put in math? F of x. That x that you put inside, that is what's called a parameter. You understand? So that's the parameter you pass. So a parameter is a variable that receives an argument that is passed into a module. So the argument of the receiving parameter variable must be of the same data type. So meaning that if you say int, it has to be int. If you say float, it has to be float. You cannot interchange it, okay? So multiple arguments can be passed sequentially into a parameter list. Any of you done calculus 2? Or even actually the end of calculus 1? And instead of just f of x, what do you learn in there? You say f of x comma y, right? So far in math, if you are lower than calculus, you learn f of x equals 2x plus 1 or something like that, right? Once you start calculus, especially the last chapter, you will cover f of x comma y, and then you may have 2xy plus y or something like that. Okay? So that's what it's trying to say here. Instead of just one argument, one parameter, you may have two. So multiple arguments can be passed sequentially into a parameter list. Okay. So a main function called when the program starts. So calls other functions when they are needed, defines the main line logic of the program. Each block must be indented in Python. Other language uses braces to break it down. So lines in a block must begin with the same number of spaces. Use tabs or spaces to indent lines in a block, but not both. This can confuse the Python interpreter. Idle automatically indents the lines in a block. Idle is basically an IDE, like kind of like the Raptor that we use online. Blank lines that appear in a block are ignored. In a flowchart, function calls as rectangle with the vertical bars at each side. Function name written in a symbol typically draws separate flowcharts for each function in the program. I'll show you this. And terminal symbol usually reads return. You have top-down design. There's a technique for breaking algorithm into functions. Then you have a hierarchy chart, depicts relationship between functions, which is what you're doing part of your project 3, aka structure chart. So box for each function in the program, lines connecting boxes illustrates the function called by each function, doesn't show steps taken inside a function. It just says this is the main function, and then from the main function, I'm calling these other functions. So the first thing that you should do is you actually write your program, you break it down into functions. It's from there that you draw your flowchart, hierarchy chart, okay? So use input functions to have program wait for a user to input. So here's basically the hierarchy chart. For this assignment, it's only asking for the first level and the second level. You don't have to do, if you have other functions inside, like subcharts. You have a local variable that is assigned a value inside a function, belongs to a function in which it was created. Only statements inside a function can access it. Error will occur if another function tries to access the variable. So the scope, we said the part of the program in which a variable may be accessed for local variables function in which it's created. Local variables cannot be accessed by statements inside this function which precede its creation. So different functions may have local variables with the same name. Different functions. Remember, like the function here, another function. They're the same. Okay, so each function doesn't see the other function's local variables, so no confusion. Ali here is not the same as Ali there. Does that make sense? Mm-hmm. Arguments is a piece of data that is sent into a function. So a function can use argument in calculation. When calling a function, the argument is placed in parentheses following the function name. So it's an example of a main function. So it's value, it's 5, show double value, and then here's when you pass. Parameter variable that is assigned the value of an argument when the function is called. So the parameter and the argument references the same value. So general format. Scope of a parameter, the function in which the parameter is used. Okay. So Python allows writing a function that accepts multiple arguments. Parameter lists places single parameter. Parameter lists items separated by a comma, so arguments are passed by a position to corresponding parameters. So first parameter receives the value of first argument. Second parameter receives the value of a second argument, and so forth. Okay. Examples of those. Changes made to a parameter value within the function do not affect the argument, known as pass-by value. So it provides the way for unidirectional or unidirectional communication between one function and another function. So a calling function can communicate with a called function. So you have value defined there, and then the value that's passed. The value variable passed to the change me function cannot be changed by it. Okay, it cannot force it. You have keyword arguments, arguments that are specific, which parameters of the value should be passed to. So position when calling function is irrelevant in the general format. You have the function name and then parameter equals value. It's possible to mix keywords and positional arguments when calling a function, but it must appear first. We discussed about global variable. It's created by assignment statements written outside of all the functions, the one we discussed. So can be accessed by any statement in the program file, including from within a function. If a function needs to assign a value to the global variable, then the global variable must be pre-declared within the function. Okay, so you can call it general format and then global variable name. You might see using this in the case of your menu. If you create a function called menu, and then you may have to use the word global to reassign some other values inside. So reasons to avoid global variables is global variables making debugging difficult. Many locations in the code could be causing a wrong variable value. Functions that use global variables are usually dependent on those variables. makes function hard to transfer to another program. They make program harder to understand, but there are cases where you need to use them. However, global constants, it's a global name that references a value that cannot be changed, like in the case of the tax rate. Permissible to use a global constant in a program, so to simulate a global constant, Python create a global variable and do not redeclare it within the function. Void function is a group of statements within a program for performing a specific task, and call function when you need it to perform the task. So value returning function, similar to void function, returns a value. Value returns a part of the program that called the function when a function finishes executing. Then we have some built-in functions called standard library functions. So library of pre-written functions that comes with a Python. They perform tasks that programmers commonly need, like print, input, range, viewed by programmers as a black box. Some library functions built into Python interpreter to use just call the function. And almost every high-level language have built-in functions, okay? Especially some of the math functions. I mean, they're regularly used, so you call them when you need it. So standard library functions and the import statements. So modules files that store functions of the standard library help organize library functions not built into the interpreter. Copy it to computer when you install Python. To call a function stored in a module, you need to write an import statement, so written at the top of the program. So you say format import module, whatever module you're trying to use module name. Generating random numbers, so these are built-in functions. So here you have random number are useful in a lot of programming tasks. So you have a random module, includes library functions for working with the random numbers. I have some of the videos loaded for you under the student resources that you can look at. So dot notation for calling a function belonging to a module. So you have module name, that function name you can call. So a int function generates a random number in the range provided by the arguments, returns the random number to a part of the program that called the function. Return integer can be used anywhere that an integer would be used, and you can experiment with the function in an interactive mode. So these are some of the built-in functions. You have random range, this function similar to a range function, but returns a randomly selected integer from the resulting sequence. Random function returns a random float in the range of 0.0 and 1.0. Doesn't receive arguments. You have a uniform function, returns a random float, but allows user to specify a range. Again, these are all built-in functions that you can use when you need, that you can look at. There's some more of these. Or you can write your own function and use it. In your assignment, you have to write your own functions, and you will be using it as you call in the main program. Okay. How to use value returning functions. Can be used in a specific situation. Example, have a function prompt the user for input and return the user's input. Simplify mathematical expressions, complex calculations that need to be repeated throughout the program. Use the return value, assign it to a variable, or use it as an argument in another function. Using IPO chart, it describes the input, processing, and output of a function. So it's a tool for designing and documenting functions typically laid out in columns, usually provide brief description of input, processing, and output without going into details. Often includes enough information to be used instead of a flowchart. It's another way. So you can have all the inputs and then the processing that happens and then the output. Returning strings, you can write a function that returns a string. For example, you say def get name and then get the user's name, input, enter your name, and then return the name. You can have Boolean functions, returns either true or false, used to test a condition such as for decision repetition structure, common calculations such as whether a number is even can be easily repeated by calling a function. Use simplify complex input validation code. So in a Python, a function can return multiple values specified after return statements separated by commas. When you call such a function in an assignment statement, you need a separate variable on the left side of the equal sign operator to receive each return value. You have a math module, part of the standard library that contains functions that are useful for performing mathematical calculations. Okay, and you have to import the math statement. So these are some of the built-in functions that exist inside the math module: cosine, sine, exponential, float, logarithm, and so forth, square root. So the math module defines variables pi and e, which are assigned mathematical values for pi and e, can be used in equations that require these values to get more accurate results. Okay. Variables must also be called using the dot notation when you need it. Storing functions in modules in large complex programs, it's important to keep the code organized. So this modularization of what you have to do for this project 3 is a group of related functions in modules. It helps you organize your program. Easy to understand, test, and maintain. So it makes it easy to reuse code for multiple different programs. Import the modules containing the required function to each program that needs it. Module is basically a file that contains Python code, contains function definitions, but does not contain calls to the functions. So importing program will call the function, rules for module names. File name should be end with a py, right? That py cannot be the same as a Python keyword. Import module using the import statement. Now let's look at how to do this in Raptor. So here is the main, right? Let's say if we want to create a module or a subchart. Here we call it a subchart. So we right click and we say add a subchart. So in your assignment, in your lab here, you have to do at least 4 or 5, I believe, right? Look at the requirements. So it says, please enter the name of the subchart. So here you can call something like, again, you have a choice on how you organize it. You write statements that belong together, okay? And make it a subchart or make it a function. So here we will just say maybe address or receipt header or something like that. Okay, so it creates a subchart. You see that? Since we called it a receipt header, so what do you think it should be here? So you make sure you're in the right subchart. So I'll drag the output. Very good. All right. So that's to save it. So we just say here test. Save it in the desktop. So here's the output. So we double click, and then here we put what we want to put. So we can put in the restaurant's name. What do we call it?
Wendy's.
Wendy's?
Yeah.
Oh, well, are we marketing for Wendy's?
Chick-fil-A.
So make up one, you know.
Julio's Tacos.
How about Chuck and Kobe's? Actually, didn't mean I meant this Shaq. Oh, you're a hater. You don't want him. All right. So let's say you give it a name like that, right? And then you can put a space in however you want. And then when you come to the second line, you say 555 Main Street, Largo. All right. You can have the phone. 202 555 1212. So what do you think all this function would have is basically the address. I mean, just however you format it to be. Now, if you want this to be called in the main function, then you call this call function. You see this? We are going to drag this here and put it right there. Now here, we will type the name we just created, which was what? Seed. Now, if I run this program, it would go here and then read it and then print it here. So let's go slowly here. Look what happens. I'm going to go a little bit slower here. So I'm going to run this. See that? And it reads that, comes back, and then it ends the program. Okay? Let's say you had another subchart and call it maybe food menu or something. Okay? And here you can do all your declaration. Maybe banana, $1.99. Another name, chicken, $2.99. Right? Then you can call that here, and then give it the name of that we just created. What was it? Food menu. Now we just declared that we didn't do anything with it, right? So we have to do ask an input, right? Like how many of these do you want, right? So here we can say how many banana do you want? And here we can say, what do we call this? And we say how many bananas do you want? Yeah, quantity of banana, right? And then we can ask another similar question, copy. And paste it there. So instead of banana, we will call it what? Chicken. And this should be quantity of okay. So again, of course, you'll do your calculation, but we just want to put it out, right? An output. Let's just make it. Let's do an assignment first. So let's do some calculation. Okay. So we can say cost of banana or something like that. So the cost of banana would be what? Quantity of banana times banana, right? And we will do the same thing. Yeah, we just, instead of cost of banana, this would be cost of chicken. And then it will be quantity of chicken times chicken, right? So basically here we're doing a calculation, and then we can output here. So here we can say quantity oops. Just copy for me, I don't know why it's not there. Okay, quantity of banana, and then we can say banana, right? And then say each at, so that it looks better. And then put banana in. And then we can say costs. And then here we can put in that calculation we did, cost of banana. So this is basically the output. We can copy and paste it right here. So replace anywhere that says banana to chicken, right? Hopefully we didn't misspell anything. I'm worried about the chicken if I misspell anywhere, but where I had capital. So now watch when I run it. Remember we have two functions. Of course, all these can be put into subcharts or functions, I just put two of them in, and all these questions can be put in one. All these calculations can be put in a subchart. Okay, it's however you design it. Okay, the whole idea is not to have these in here, but I just showed you a couple of them. Let's run it. So it goes through here, reads the header. After it reads the header, it goes back, says read the food menu. So it read the food menu. Then it goes back. Now it asks how many chicken do you want? 2, no banana. Then it asks how many do you want of these? And say 5. And it does the calculation. Then it prints it as a receipt. You see that? Of course, when it asks this question, how many of these do you want to show the price. We discussed this in your labs, right? Like you want to say, plus sign, and then put each costs like a space, and then say something like a banana, so that when you ask the question, it actually shows up with the cost right next to it. Now, of course, you want to do it for each. So now it shows each costs that. All right. So now we have an idea how much we want each, and you do the same thing here, and it calculates. All right. So again, all this you can put it also in subcharts. So this is how you create basically a subchart, and this is how you call those subcharts or those functions. Capish? Easy. Now let's look at that. Again, this project you're supposed to do about 4 or 5 of these, break it down. So all that's happening in the main is just called the function call or the subchart calls. Then I'll show you how you can do it also in Python, even though you're not required at this point. You'll probably do it in project 5 or so. So let's say, we do in Python, when you define a function, you say define. And in our case, we called it what in that example? Receipt header or something like that. That's what we called it. So receipt header, and then you press, once you do the parentheses because it's a function, and then we press enter. So automatically it gives you a tab, right? And then here you can print, and then here you can say the name, Jack and Sarah restaurant or something like that, right? And then you can put a /n. What is a /n? A new line. You can have a new print, like you can have multiple prints, or you can just put a /n in there and then give the address 5555 Main Street, Largo, Maryland. Okay, and then do maybe a /n for the phone. 22555 1212, something like that. Right. So now if I run this, would it give me, would it print the address? No. Why not? We have to call it the same way in the Raptor. Remember, we after we created the subcharts of the functions here, we called it here. So the same thing when you create a function, you have to make sure that you're actually calling it. Okay, so here we call it, we say receipt header, like that. Now, because we are calling it now, when we run it, it should give us the address, the header of the receipt. Does that make sense? The same thing, we can, what do you call it? Create your other inputs the same way here. Maybe the questions. Let's declare some variables. What am I thinking?
Thinking about getting the number of banana.
Okay. Banana. $2.99, chicken, $1.99, and then we can create the input, right? Quantity of banana, input, how many banana do you want? And then quantity of chicken. It's going to be an integer since it's quantity of something, right? And then how many chicken do you want? Then after that, we have to do the calculation, right? For each item. Cost of banana equals banana times quantity banana, right? And then cost of chicken equals chicken times quantity of chicken. And then here we will do after that what? The print. And then the print will be what? The quantity of banana and then each at banana costs, and then it will be cost of banana, right? Now we need 2 of these. Again, in your case, you might need 5 of them, right? Instead of banana here, this would be chicken. This would be chicken. This would be chicken. This would be chicken. Right. And then if we run it, how many bananas do you want? 2. How many chicken do you want? 3. And you would say 2 banana each at that, yada, yada, yada. All right. How about if you would put this whole thing in a function? So we would say define order or something like that. Again, see how it automatically gives you the tab? Make sure everything is tabbed. Tab. Tab. Now remember earlier I just run it and it gave me. Right now, do you think if I run it that it would give me this? No. So which means what? I have to call it. What do we call this? Customer order, right? Oops. I'm putting semicolon in. Other language you have to do semicolon. Now if I run it, it will give me the same thing. How many of these do you want? How many of that do you want? And then it prints it. Now, the only problem is it's mixing my questions within the receipt. Do you ever see a receipt that has, what do you call questions inside of the when you are taking the order? Okay, so we have to make sure these questions are not mixed with this. So what do? We can call this, cut it from here, okay, and maybe place it right here. Do you think? Can we do that? Oops. Okay, how many bananas do you want? 2. How many of these do you want? 3. Now you see that? Now we have our address, and then we have our receipt. Now the questions are all where? On top. So you make sure that you organize it well. And the other thing is you need to clean this up, because what's happening after the address, automatically you have the order. So you might want to put maybe a /n here, and then put some dashes in or something like that, so that it looks better. It's all about presentation. So if I say take the order now, how many of these do you want? How many of that do you want? Look at that. It gives you that, and then now you have a space, and then this cleaned up. Again, after the order, when it's printing, maybe you might want to put maybe another line here or something like that. You can put a line here and say print, put a quotation in, and just put a space in, like nothing in there. You can do that. Now look when I run it. So you can put 2 of that, 3 of that. Now you see that? You have your address, you have your line, and then you have, it's all about presentation, format. Okay, so that's your header, and then you can throw another function in here and call it define function, because you also want to do maybe the footer or something, or receipt footer or something like that, right? And then here, all it does is to say, thank you, or you can put a /n. Actually, you don't really need it, but it's a good practice. So you can put a /n, and then.
You say you don't need an N. You need the
No, she's talking about the parentheses. Say thank you. Come again. Right? Then /n. Now, will this work if I run it? This thank you, will it show up? I have to call it. So we come here, and we call that receipt, called receipt header. Receipt what? Receipt header. Receipt footer.
Have you pressing enter?
Where?
After the customer order to pull up that new line where you put receipt footer.
This.
So we're doing on line 20, right?
Uh-huh.
And you wanted to create line 21. If you press enter or tab.
Enter.
Enter. Okay.
Yeah. So when I run this, so how many of these do you want? How many of that do you want, right? So now it shows you it's formatted, and then the thank you comment. So things are not jumbled up. Some of you, I put a comment in, space it out, format. This is what I'm talking about. Okay, so give it some space, format it, so it actually looks like a receipt. Okay. And then another thing, I left out is what? You have to make sure that you don't forget to comment your program. Who wrote this program, right? When was this? Right? This program does this or that. It takes orders of customers and print receipt, displays, whatever you want to say. Make sure the functions that you write, make sure you comment and explain what that function does. All right. So that is it. Basically, you can do it in Python as well as Raptor. Now, as part of the requirements for this assignment in Project 3, it says you'll use your previous programming where you left off, and be sure to copy and rename your file. Project 2, all the calculations occurring in the main program. For this project, you have to modularize your program. Design your own hierarchy chart, similar to this, in the food truck, rather than trying to recreate all boxes. Once you have settled on the structure, modify your Raptor Flowchart that you submitted for Project 2 so that the different tasks are performed in calls to tabs, right? Also, be sure that the names you come up with for your modules are verbs and follow case conversion. Please do not create modules for every single input or calculation. Programmers group statements together that accomplish one task, such as getting input from the username and appropriately, such as get input. Make sure every input displays a cost or money owed. Okay, the results of running your program could be identical to the results you obtain in project 2. All right. If the money given is not enough, make sure you loop back or with a decision stage to ask for more money. So if the money is not enough, you ask for loop. We did that last class. Okay. You will submit both your hierarchy chart and your working Raptor flowchart. You do this in one step, meaning that you select both files at the same time and upload it. All right. Any question?
You draw the hierarchy chart in Microsoft.
In Microsoft Word.
Yeah, how do you do it?
Yeah.
Oh, it's part of the art.
Okay.
Yeah. What do they call it? The art guide. Or you can draw the line. You can use the lines. You can have horizontal line in the art section. Use the horizontal line. And then you need one horizontal and then vertical pointing to each. So you draw the boxes, leave a couple of spaces, draw these, and then draw those two lines there.
Okay.
One vertical, one horizontal.
Can we do it in another program but put it to the Word document?
You can do it in another program, copy it and paste it on there.
Okay.
Yeah, that's fine. All right.